Okay, number 12. So, right, a pump is inflating a spherical balloon. Okay, so it's a sphere and it's getting bigger. So we're talking about the volume of a sphere. There's my equation. Okay, there's my equation. Right, the radius of the balloon is increasing at a rate. So the radius of the balloon, so what are they telling me? The radius of a balloon is increasing at a rate. That's the rate of change of the radius. So that's dr with respect to time. Dr dt is equal to 1, right? When the length of the radius is 2, so the length of the radius is 2. Now just be careful, girls, this is centimeters per second, right? And the radius is 2 meters, so I need to turn that into centimeters so everything is in the same unit. Is that okay? So that's not until the end, okay? I don't need that until the end, right? Okay, but and then it says find the rate at which the pump is working, as in the rate of change of volume. So what am I looking for? The rate of change of volume. What would that be? Volume's changing with respect to time, so that's what I'm looking for. So part 1 says find dV dt, right? Okay, the rate of change of volume is dV dt. The rate of change of radius is dr dt. The rate of change of area is dA dt. So rate of change is always dt on the bottom. Okay, is that alright? Okay, so I'm looking for dV dt. So the equation I have is it's a sphere. So it's the volume of a sphere. So I can differentiate that. What will I call it? dV dr. Because you're differentiating it with respect to r. So you're differentiating v, right, with respect to r, as in the variable that's over here is r. Right, okay? Bring the 3 down in front, right? So it'll be 3 times 4/3 pi, reduce the power by 1, so r squared. And 3 by 4/3 is just 4, so it's 4 pi r squared. So dV dr equals 4/3 pi r squared. Now, they didn't ask me for dV dr, they asked me for dV dt. So I have to say, well, they're looking for dV dt. So I split it into 2 fractions. Okay, so dV goes on top and dt goes on the bottom. Right, okay. And then you look around, and what's a d what in the rest of the sum? What have I mentioned already? dr, so I put a dr here and a dr here. Right, is that okay? So that's equal to dV dr is 4 pi r squared, just calculated it, multiplied by dr dt, they told me was 1. Right, so that means dV dt is 4 pi r squared. Is that okay?
Excuse me, would all instrumental players go to the concert hall now, please? All instrumental players to the concert hall immediately.
Now, I think I need to substitute for r, don't I? Right, okay, because it's at that moment. Find the rate at which the pump is working, the rate of change of volume, right, okay. I think when the radius is 200, is it? Or, yeah, is that okay? So I have to fill in r is equal to 200 into that. So that would be 4 pi 200 2b squared. So that would be a lot. 4 noughts and a 4, and 4 fours is 16. 4 noughts and a pi. Is that alright? Okay? Are we okay with that? Right, part 1. Right, part 2. Can I move it up? Sorry, are you ready for me? Can I do that? Scream if I can't. Right, part 2. It says, if the air continues to be pumped at this rate, right, okay, so that means dV dt is equal to 160,000 pi. Okay, so I have that. That's what they're telling me, right? Okay, find the rate of change of radius. So I'm looking for dr dt. So this time the dr dt is changing. It's not 1 anymore. But they said dV dt is the same. So that's what dV dt is. right? Okay. Find the rate of change of the radius when it is 5 meters in length. So r is equal to 5 meters. I might change that to 500 centimeters because everything's in centimeters. Okay. Find the rate of change of the radius, which is 5 meters high. So I'm looking for dr dt this time. Yeah. So dr dt. Sorry, before I do that, I have my formula already, 4/3 pi r cubed, and I have dv dr already. When you differentiate that, you get 4 pi r squared. I did that already, okay? But that's still valid, okay? Is that okay? So there's the rate of change they told me about. Here's the rate of change I'm looking for, and here's my equation. So 3 things in a question, right? So the rate of change they give you, the rate of change you're looking for, and an equation, right? So sometimes they're not obvious, you have to figure it out yourself, okay? So I'm looking for dr dt this time. So dr dt, right, this time split it up into 2 fractions. I put dr on top of the first one, dt's on the bottom, right? And for the rest of them, what do I put in? So I look around this part of the question, d what is here? dv. So dv is there, isn't it? There's a dv there, and there's a dv there. So it's dv. Okay, right. So this is dr dv. Now I have dv dr. What'll I do? dv dr. This is the same thing except it's upside down. So you just invert it, right? Okay. So if I just, that's over 1. So if I invert it, I now have dr dv. Okay. So all you have to do is turn it upside down. So it's 1 over 4 pi r squared. Is that all right? And you're going to multiply that by dv dt, which was 16, 1, 2, 3, sorry, 4, 5 pi. Okay, pi's will cancel anyway, and I'm putting in 500 for r, so it's 1 all over 4 times 500 to be squared multiplied by 1, 6, 1, 2, 3, 4, 5. Yeah, you get what you get. That would be 100, and you knock off 4. That would be 4 over 25, I think it works out to be. Is that okay? When you work all that out on the calculator, right? I think it's 4 over 25, but I'm open to correction. Right, are we good? Okay, questions? Right, no. Right, part 3. At what rate is the surface area of the balloon? So now I'm looking for the rate of change of the surface area. So that is dA dt, isn't it? I'm rate of change of area. That's what I'm looking at. Right? R is 5. So that means all of the previous questions, right, anything in here is valid. So I just worked out dv dt, didn't I? I think that was, no, that was dr dt, sorry. That's dr dt I worked out there. So I can take that answer. Dr dt equals 4 over 25. So I have a rate. I know the rate I'm looking for. What am I missing? What do I need? An equation, don't I? Right, okay. So it's the rate of change of surface area. So off you go to the log tables and you get the surface area of a sphere, which is 4 pi r squared. So there's your formula. I can differentiate that and call it dA dr. Differentiate that and you'll get 8 pi r, sorry. Differentiate that and you'll get 8 pi r, agreed? Okay, so I'm looking for dA dt, so dA dt split it up. That would be dA on top, dt on the bottom, and the other one you're missing is dr. Is that okay? Right, so dA dr, just got it, 8 pi r. Dr dt, it's the same as the last one, 4 over 25. And then I had to put in r is 500 into that. Okay, so yeah, yeah, you get what you get. I don't know what you get. Does anyone know what you get? Yeah, whatever you get what you get. Is that alright? You have to put in a pi for that. 8 pi by 500 multiplied by 4 over 25, and that's what you get. Is that okay? Are we alright? Everyone okay? I know they're not easy, okay, but if you keep it in your head, they're going to tell me one rate, they're asking me for a rate, so they're telling me a rate, they're asking me for a rate, and I have to find an equation somewhere. So if they don't give you an equation, girls, it'll be the volume of a shape from the log tables, or it'll be the area of a shape from the log tables, okay? Right, because you have to come up with an equation somewhere, okay? So if they don't tell you, as in the easier ones near the start, they gave us an equation and it was grand, okay? In the later ones, you have to find the equation, but it's in the log tables. Bear that in mind. It's going to be the volume of a shape or the area of a shape. Got it? Okay, so they'll tell you a rate of change, they'll ask you for a different rate of change, and you have to have an equation to start with. Okay? Right. 14, am I doing it? No one's speaking. 14, yes, no, maybe? I'll take that as a no. Right, okay. Right, then I asked you to look at the revision exercises. So will we skip to the ones you had problems with, because you're getting a test on this chapter tomorrow? So, right, number 1, okay. 2, 3, how about you tell me? 7, right, okay, so number 7. Okay, the equation of the circle is y equals x sine 2x, and it says find the slope of the curve. So the slope of the curve is dy dx, isn't it? So you have to find dy dx. When x is equal to pi over 3. Now, I told you we're talking about angles, didn't I? So when you're talking about angles, pi is how many degrees? 180, right? Right, okay, so that's 60 degrees. Now, if you're talking about just a number, it's pi, 3.14, okay? But if it's in relation to angles, it's 60 degrees. I don't want you to sweat about that, because I won't give you a trigonometry one tomorrow, right? Okay, and when we get on to trigonometry, this will all make a lot more sense, because we'll know what it's all about. Is that all right? Okay, so don't sweat it, right? Okay, but I'll still do it, right? This is the product rule, isn't it? It's a product. It's x multiplied by sine 2x, right? Okay, so u is equal to x. I just said there won't be one tomorrow. No. Right? Du dx is equal to 1, and dv dx is differentiate sine, and you get plus cos or minus cos. You get plus cos, is it? Yeah, sorry. You get cos 2x, and then you differentiate the angle multiplied by, then you differentiate 2x multiplied by 2. Is that right? Okay, then put it together. So the product rule says it's u times dv dx, which is, I might just put the 2 at the front, 2 cos 2x, is that alright? Add v times, which is sine 2x, times du dx, which is 1. Right? Is that okay? Then, listen, I'm not even going to bother multiplying that out. Right, okay, if it's just a regular number, right, okay, it's pi over 3. Right, as in pi 3.14 over 3. Right, if it's an angle, it's 60 degrees. Okay, right, so that's just a regular number, isn't it? So that means it's 3.14 divided by 3. Okay, here, this would be 2 times the cos of 2x, that's an angle, so 2 times 60 is 120 degrees. Is that okay? Plus sine of, that's an angle, 120 degrees. Okay, into the calculator with that. Okay, and I think the cos of 120 is possibly minus a half. Cos of 120 minus a half. Anyone do it? That's minus a half, I think. What's it as a fraction? Root 3 over 2, so is it? I'll just do. You could have your calculator in radians. Cos of 120. Does it say DEG? Oh yeah. Oh yeah. No. Yeah. I'm just doing this bit. So it's pi over 2, pi over 3, times 2 times cos of 120 is minus a half, and the sine of 120 is root 3 over 2. Just multiplying out there, that would be minus root 3 over 2, sorry, minus pi over 3 plus root 3 over 2. And that's your answer. Okay?
Excuse me, please, could the following come to reception at the bell, please? Rachel O'Connell, Amina Husseini, Weaver Griffin, Aoife Sullivan, Abby Kelly, Sarah Mead, Emer Conroy, Blauhin Musgrave, Siún O'Keefe, Ella Georgia O'Shea, Alison Carey, Emma Diffley, Rachel or Heather O'Connell, and Linda Walsh. Also a reminder that study is on Saturday, Sunday and Monday this weekend. Thank you.
Right, okay. Any other questions? Please be proactive about your learning now and ask for the questions you need. Was everything else okay? 10, yeah. Okay, so 10. The equation of a curve is y equals x plus 4 over x. Show that 2, 4 is the minimum turning point. Look, I'm looking to find the turning points. Okay, so I'm looking to find the turning points, and that's 11, right? Okay, thank you. Right, find the volume of the cube of edge x is increasing at a rate of 42 centimeters per second, centimeters cubed per second. It's a cube, right? We're talking about the rate of change of volume. So what's the rate of change of volume, please, expressed as d what, Rate of change of volume, what I call it? dV dt. So the rate of change of volume is dV dt, and they're telling me dV dt is 12 centimeters cubed per second. Okay, so dV dt is 12 centimeters cubed per second. Right, listen, I'm clearly going to talk about the volume of a cube. So what is the volume of that cube? X to the power 3, isn't it? It's x by x by x. Would you agree? There's my equation. Right, okay, and then they ask me, find the rate of increase of the length of the edge of the cube. So the edge is x, and I want the rate of increase of x. So what is that? What am I looking for? The rate of increase of x. What's that? dx dt, isn't it? That's what I'm looking for. The rate of change of x, of the length. So remember, I said you need an equation. They have to tell you a rate, you need to look for a rate. Okay? Right? So I can differentiate this, and when I differentiate it, what do I call it? dV dx. So you're differentiating v with respect to x over here. So dV dx would be what? 3x squared. Right, so then I want to, sorry, they also tell me the volume is 125. So what does that mean? If the volume is 125, what's x? 5, yeah, because 5 by 5 by 5, isn't it? So that's for the end. I'm going to be filling in x is 5. Is that right? Okay, yeah. Yeah. Right, so I'm looking for dx dt. Split it into two fractions. dx on top, dt on the bottom. What's the other one? dV. Right, so this is dx dv. Now I don't have dx dv, I have dv dx. So how do I get dx dv? Turn it upside down, yeah? So it's 1 over 3x squared. Agreed? Okay. Then dv dt, they told me it's 12. Right? Okay. So in 12 by 1 is 12. So that's 12 all over 3x squared. 3 into 3 goes 1, 3 to 4 goes 4 times. That's 4 all over x squared. So that's what dx dt is. And instead of x, put in a 5. So it's 4 all over 5 to be squared, which is 4 over 25. So they're telling me put in a 5. Okay, is that alright? Yes.
So you know how whenever you like turn indicate that was at the bottom of a fraction back up to the top and it turns into a negative, why doesn't it do it here?
Because you're inverting it as opposed to you're changing it as opposed to, you know, if you were like 1 all over 3x to the power minus 2 is the exact same number. I don't want the exact same number, I want that number upside down. So if you're looking for the exact same number, then you change the indice. But if you just turn it upside down, change nothing. Just turn it upside down. Is that right? Okay, so this is the exact same number, but I don't want the exact same number, I want the upside down number. Okay, right. Any more questions for me? That's 10. Any more questions? Any? Even go back the way? Okay.
Could you actually do 9 as well?
Yeah, no bother. Right, 9. The number of salmon swimming upstream in order to spawn is approximated by, so S of X, that's just the number of salmon. Can I change that? I hate those X of, yeah. Yeah, so I'm going to just change it to the number of salmon. Is that okay that I do that? It makes more sense. I always do that because it makes more sense to me. Right, so the number of salmon is minus x cubed plus 3x squared plus 360x plus 5,000, where x is the temperature of the water. Right, so x is the temperature of the water, right, in degrees, and this function is valid only if x is between 6 and 20. So they're telling me x has to be between 6 and 20, right? That's just an extra condition they've added to it, right? Okay, find the water temperature that results in the maximum number of salmon. The keyword there, maximum number of salmon. What am I looking for? Maximum. What am I looking for? A dy dx, and it's a turning point. It's a maximum turning point, so dy dx equals 0. Agreed? So get dy dx, so you'll get minus 3x squared plus 6x plus 360, and you know at the turning points that equals 0. So we're solving. So what I'm going to do is divide across by minus 3, so that's x squared minus 2x minus 120 equals 0. Factorize. So it's x and x, 10 and 12, and a minus and a plus. Right? So that means x is equal to minus 10 and x is equal to 12. But what's the story? They told me at the top of the question that x had to be between 6 and 20. So this is clearly not between 6 and 20, so it's not an answer. So, and you don't need to find the maximum. Do you need to find the maximum? Find the water temperature, that's all. So it's just find x. That's it. Job done. Good? Right? Number 9, any more for me? No? Really? We're okay? How am I going for time? There's 7 minutes left, so do you want to look over stuff yourselves and ask me questions?
Yeah.
Right. Okay, you've 7 minutes to, it is 7 minutes, I always get mixed up with this one. So